Good afternoon, ladies and gentlemen. Welcome to today's Open Classroom webinar from an unseasonably wet and cold Cape Town. I trust everyone is well. In today's webinar, we welcome back Cameron Boyle, who many of you will know from our Johannesburg office. During Cameron's presentation today, please feel free to use the text chat service on your GoToWebinar app or webpage to ask us any questions you may have during Cameron's presentation. After today's webinar, we'll post a video copy on our website in the webinar section. So, good afternoon again, Cameron, and please take it away.
Thank you very much, Charles. Good afternoon, everybody. Welcome to today's webinar. Thank you for joining us. Today, I'm going to show you how you can utilize your CAD module together with your roads module to go and create a roundabout design using the Stockdale method. But before doing so, I'm going to use this opportunity to tell you a little bit more about our BIM or our IFC export functionality. I'm going to show you how easy it is to export to IFC and then open up the IFC file in a freeware software program called BIM Vision. In my CAD mode, I go to File, Import Export, Export to IFC. While I'm doing this export, I'm going to give you some additional information with regards to our IFC files. While many organizations have jumped on the building information modeling or BIM bandwagon, at Civil Designer Software, we have recognized that true interoperability depends on the adoption and implementation of vendor-neutral international open standards for assets pertaining to civil infrastructure. For this reason, we choose Industry Foundation Classes or IFC Open File Format Specification developed by Building Smart for BIM Workflow Data Exchange. We developed our first IFC export module in collaboration with Kia Construction in Europe more than 3 years ago. Since then, we have continued to improve its versatility. Civil Designer's IFC export functionality allows all geometric data in a project to be exported as one or more IFC files to be used as part of any BIM workflow process. Our IFC files contain 3D model, geometry representations of a project's objects, in addition to the associated properties and quantities. The IFC export files can be written from any of Civil Designer's design and analysis modules and can be utilized in BIM 4D and 5D. We commend Sanrail for their transition to BIM as stated in item C3.1.16 of Sanrail's tender specification and their efforts to develop open data standards or model view definitions compliant with Industry Foundation Classes or IFC data models. Civil Designer more than meets these requirements with the ability to export 2.3, 4, and 4.1 IFC files. I hope you found that IFC or BIM section informative. Please do let us know if you've got any additional questions. Moving back to the Stockdale roundabout design, showing you what we want to achieve by the end of this and viewing it in a 3D format. If you're not aware of it yet, in 1978, Mr. R. Stockdale published a paper titled The Vertical Alignment Design of Roundabouts. Since then, this method of vertical alignment roundabout design has become widely used. This method was first introduced in the 2015 version of Civil Designer. We have since then had numerous requests to show an update in our webinar series. Just to give you some additional information as far as this design is concerned, the roundabout function can have 3 or more incoming roads. The roundabout can be non-circular, and you can use line arc line, polylines, splines, or even CAD arcs for the CAD portion of your design. I'm going to leave this project now and go back to the beginning of the design. I'm going to show you how to use the CAD, drape it onto the road in order to design the roundabout. Looking at the roads first, I'm going to go and turn off all the unnecessary CAD layers at this stage. And before you do the actual design, there's a couple of things that you need to look at for verification purposes. One of the first things is to see that the roads are able to drain, and there's different ways of doing this. And then go to the terrain mode, graphical on top, and go and select annotate slope. Specify which setting to use, pointing out that I'm using the existing strings model for interpolation. Specify where you want to start the slope determination and then put in the next point. And you'd preferably want to go and do this for all 4 roads. I'll just do it for the one road showing you the example. Then moving on to the display settings, selecting your road strings. On the top right hand side, you can go and specify which drainage display settings to use. As an example, anything less than 0.5% slope will be highlighted in red. You have the option of showing high points as well as low points. And if you want text associated with those points, you can go and specify which settings to use. On the bottom left-hand side, you can turn on your road contours, specify things like your interval, and then on the bottom right-hand side, go and put in slope arrows. Also need to mention that roads need to begin or end at this circle, therefore you might need to segment your roads. As an example, if this minor north and south road was all one road, you could then go to your roads mode, select file on top, select road file, specify which road you want to segment, and then click on that icon. And Civil Designer would guide you through the segment process. And then cancel this and make changes to my display settings. Your roads also need to be dual carriageways. If you look at the north and the south road, they look like single carriageway roads, but they're actually dual carriageway templates. If I select the north road, I go to Tools, Template Paths, go and select this dual to single template, right-click and select Template Editor. What I've done is I've gone to the carriageway settings, I've selected the dual carriageway, and then I've made the pivot to median breakpoint 0, as well as the pivot to centerline point 0. I've done that for both sides. So essentially, the pivot points are the center lines. And remember this because we use the pivot points during the design process. Click on OK. And then looking at your layers. You want to ensure that your layers aren't going past the center line. So looking at left layers, specifying you want the median point, and the offset from the median point is 0. Same thing applies to the right-hand side. If you look at the cross-section or the profile in front of us, it looks like the one carriageway is a lot lower than the other. This is by default, and this is in order for you to determine the difference between lower and upper median. But your pivot points or the center lines are really picked up from your vertical alignment. Taking a quick look at that, I can go to alignment on top, select vertical, edit alignment. If you want to ensure that your elevations are the same for the left and the right hand side, you can simply go and right click on the selected cells, copy them, go to the right hand side, and then right click and paste. You'll also find that when you go and select a road, you right click, go to road operations, and give you the option to change it to a single or dual carriageway. Something else worthwhile mentioning is if you go to alignment, edge levels, edit super, you can go to widths at the bottom and you can go and make changes to the distance of your pivots and your median breakpoints. You can see the appropriate cells are 0 in this case. Now I showed you the pivot points in the cross sections of your template. Let's look at them from the plan view. I'm just going to go to my CAD layers and turn on the pivot points. We use these pivot points as the cross-sectional grade of the road will change along these points. The approach, left and right pivot strings are adjusted and heighted to follow the crown lines. Which crown lines, you may be asking? I'll explain that shortly. With the road explanation out of the way, let's go and turn on some CAD layers. These CAD layers that I have in front of me were drawn using the track generation functionality. With this function, you can take portions of your road and create a CAD layer from that. As an example, with the North Road, let's go and put in our center line. So you can see the North Road here is selected. Go to Alignment, Horizontal, Track Generation, specify start and stop chainage. That's why you can see in some cases I've only got portions of the road. Specify your offset from centerline, which pen colors to use, and then also go and specify where you want the resultant layer to be. Once I click on OK, look at the North Road and see how the center line's been generated. Now that we've established where our roads are joining into our roundabout, we need to go and put in our center circle or center crown line. These are not necessarily the highest points in the cross section, but are rather imaginary lines which usually indicate a change in the degree of crossfall across the road. Taking a look at that in our control center. At the bottom, selecting layers. Turning on the crown center circle. This crown line must be approximately 2/3 the distance between the central island and the outer road edges. So turning on those CAD layers, there's the road edge, and then turning on the center island. The center circle will be 2/3 the distance between those two newer layers I've turned on. Now looking at the approaching crown lines, these are CAD arcs. Taking a closer look at crown line number 1, you'll see it starts on the pivot point of the northern road. Then I've used a tangent snap to jump to the center crown line, and again joined to the pivot point of the western road. Once the crown lines are in, you are able to establish where the kiss points are. Looking at the kiss points, I'm turning on that CAD layer. You can see it's the tangent points between the center crown line and your incoming road crown lines. In order to explain these kiss points, let's open the previous project and edit the junction. So again to the finished design, selecting junctions, edit junction. So at the same time, I'm showing you that it's quite easy just to edit an existing design. Click on the junction and viewing it from a long section perspective. Civil Designer automatically picks up the existing grades of your approaching roads. As an example, minor south, it joins it to your west road grade and applies an S-curve between the two roads. Where that S-curve intersects the center crown line, that is what we refer to then as your kiss point. Once we have established all the kiss points, the roundabout crown line will be drawn in using a cubic spline. We'll still get to this stage. Closing this and then moving back to the original design. The reason for selecting this particular project is you can see that the roads aren't quite lined up, and the road widths of North and South Road are different to East and West Road. Because of this, you need to be careful when you put in your road edges. Let's look at that in more detail. Turning off those kiss points. And then turning on my geometry lines. Focusing in on crown line number 1. In order to put in this road edge, I've gone and put in 3 geometry circles. The first circle being tangent to the northern road edge, the second circle being tangent to the western road edge, and then where the kiss point is, I've divided that distance into half and put in my third circle. Using that information inside the CAD mode, you would go to Draw, select Arc through 3 points. Turning off the geometry lines. And then turning the roads back on. Let's start with the actual roundabout design. Here we can see a nice example of how the CAD and the road module integration works. Going to my roads mode, no need to go and select a road file. Civil Designer will automatically create a road file for us during the design process. Then go to junctions on top and select add roundabout. Reading my prompt, it says indicate roundabout crown. So I go to the center crown. With it selected, I can go and right click and extract string. Moving on to the next prompt, it says indicate entry or exit crown number 1. So I'm going to the blue line, left click. You can see it selected, right click and extract string. Reading my prompt, it says indicate the entry point. I want to be in exactly that particular point there, so I'm going to go and select the grab all snap mode. Going to that point, I'm going to go and left click. Reading the prompt, I need to indicate the exit point. And the last prompt in this process is to indicate the road edge. Again, to this red line, left click, with it selected, right click and extract string. With all the elements selected on the plan, I'm reading my prompt. It says, are you satisfied with the crown line number 1? Before I click on yes, you can go and specify the coordination interval for your crown lines. I'm happy with 5 meters at this stage, so I click on yes. Do you want to add another crown line? I've got 3 more to go, so I'm going to click on yes. Changing my zoom view. Reading my prompt, indicate entry exit crown line number 2. Now this doesn't particularly have to be one line. If you're using the line arc line functionality, you can select the entities individually. Specifying the entry and the exit. You preferably want to do this in the direction of travel. Selecting the road edge and then right click and extract string. Satisfied with it? Yes. Yes, I want to add another crown line. Changing my zoom view. Selecting my incoming crown line. Right click, extract string. Again, specifying the entry point and the exit point. Now with this prompt, if your incoming and outgoing roads have the same road widths, you could simply press escape here to use the existing road shoulder width. But in this example, I've gone and drawn in my own width. So I go and select it and then right click and extract string. Satisfied with line number 3 and adding in the last crown 4. If you've selected a line and you find that you've made a mistake, you can always go and right click and redefine the last entry. Having done that, you'll see the long section appears. Let's look at this in a little more detail. I'm going to my display settings and then switch everything off and then only leave on Southwest Road. At the bottom here, you can go and specify additional information you might require. And then make the active string Southwest Road. And then looking at the ground lines, if for instance you wanted your ground line on, you could turn it on here. Clicking on OK. Now, as I move my cursor on the long section, you can see there's a cross in the plan view. It gives me a good indication as to where I am. And if I zoom into that point, you can see this is the kiss point where the two lines intersect. From this, we can see civil designers picked up the existing grade of South Road and the existing grade of West Road. It then goes and applies an S-curve, and where that S-curve intersects the kiss point, that is where our vertical alignment crown line is going to be placed using a cubic spline. So just taking a look at the center crown line, if I go back to display settings, go and turn that on. I could even go and make it active again. You can see that the circle center crown line would go through the kiss point. And this is done using a cubic spline. Turning on all the other roads, that is what the end result would look like. As an example, you could go and click on a point and you could go and make changes to the elevation. Also give you a whole lot of tools that you can use on the left hand side. You'll find that in Civil Designer 8.4, this is a new tab, apply a spline through a point. So you can go and click on 2 points and then a point where you want the spline to go through. I'm happy with the design, so I'm going to go and close it. Looking at the next dialog, you can go and specify where you want to put it. Let's put it on road 3. And in honor of Mr. Stockdale, let's go and call it Stockdale 8.4. Looking at the diagram in front of us, there we've got the dimension of L, and that is your lane width. So you can simply go and change your lane width. Looking at the crossfill, so we're going from the crown line, we're going in towards the center. There's your specified grade. And then looking at tie-in slope at B, that would be from your crown line out towards your existing road, where you can go and specify which grade to use. Clicking on OK, and then going through the design process. If you've done a road design before, you'll find this dialog familiar. So we're going to extract the cross sections. Specify where you want the result. And then change in my view. And then go and turn off that one CAD layer that we no longer require. So taking a look at our design, let's go to our display settings. If you want to go and make any changes, you can go to your plan layout. There we've got the Stockdale 8.4, where you can go and specify what settings to use. And in my example, I want to turn off the transparency shading. Looking at different tools that you can utilize to make changes to your design, your width and crossfalls could be edited under your edge control. So looking at your crossfalls at the bottom there, as well as your widths. You could also go to junction and edit the junction, and that's what I did in the previous example. You could simply go and delete the junction, and we also give you the option to review the junction. Let's go and look at that. Specify where you want the results. In my case, I selected the output window. Let's go and see what that looks like. Now, listed in front of us, you can see there's Minor South Road, all the information associated to Minor South Road. So we're looking at the different names, your coordinates, your chainage values, and your bearings. Going further up, there's the East Road, looking at North Road. Now looking at the coordinates, it's listed from this position here going up to the north side, and then starting over here and working again back up to the north side. With my output window still open, I'm going to show you how you can calculate your quantities. I go to area volume, mass or volume, go and specify which settings to use, click on calculate, and then results to output. Now the inside portion of your roundabout will use the end area method, whereas the junction portion, as indicated here on the right hand side, would use the triangular prism method of volume calculation. Also, a very useful function when it comes to junction design is using the add-on strings. In order to explain this, I'm going to go and turn on a CAD layer. These are polylines, and please ensure that your polylines are closed. So I'm going to convert those polylines into islands. I do so by selecting the appropriate road. Inside the road mode, I go and select Tools, assign add-on string from polyline, click on the polyline, specify a name, chainage interval on my straights as well as my arcs, and then select the appropriate curb from a whole library to choose from. Same thing applies to the other road. Ensure that you've selected the road. Go back to Tools, assign add-on string from polyline, click on it. If you're happy with the settings, click on OK. Right-click and quit. And before we view it in a 3D format, I'm going to turn on a water feature, and this is a 3D CAD drawing that I've created purely for aesthetics. Viewing it in a 3D format. Thank you very much for joining us today. Until next time, cheers for now. Back to you, Charles.
Thank you, Cameron. That was very interesting. And thank you very much to all who attended today's webinar. Please remember, if you would like any further information with regards to Civil Designer, or if you would like to request future webinar topics, as was the case today, please use the email address listed on your screens right now. Once again, thank you very much for your time today. Have a great afternoon, weekend, and goodbye for now.